Hello, this lesson is on mass stoichiometry. So we cannot physically measure moles, therefore we're going to use grams. And if you're given grams, you're going to have to convert them into moles using the molecular mass. So that's just a mole conversion, going from mass to moles. Once you are in moles, you can then use your mole ratio from your balanced equation to get to moles of what you want. So we're taking things that we've already learned and we're going to put them all together. Now, if they're asking you for moles, you're going to stop there. Remember, you're going to stop with whatever unit that you're looking for. So if you're looking for moles, no need to go any further. However, they're typically going to ask you for grams of something else. So if they want grams, take the moles that you've been given, turn it into grams using the molecular mass of your wanted compound. Again, a mole conversion. So a general equation for mass stoichiometry is you're going to start with however many grams you've been given. You're going to turn that into moles using the molecular mass of the given compound. Next step is the mole ratio. From your given reaction. And then the molecular mass of what you want. Remember, the G there is for the given, the W is for the wanted, and the A and B are the coefficients from balanced equation. Molecular mass, so you got to find that of the compound. Remember, anytime you see grams, you got to find the molecular mass of the compound. So you're going to do a mole conversion to get from grams to moles. That's this piece. Then you're going to do your mole ratio. Then you're going to do another mole conversion to get from moles to the grams of the substance that you want. So let's calculate the number of grams of ammonia produced by the reaction of 5.40 grams of hydrogen with an excess of nitrogen. I recommend, first of all, identifying what you are given and what you are finding. So we have been given 5.40 grams of hydrogen. So that means in our balance reaction, we're only going to be looking at the hydrogen. And we are looking for grams of ammonia. So we're only going to be dealing with grams of ammonia. You don't need to use the nitrogen. Excess means extra. We don't have to use it. You can't type excess in your calculator. So we're not going to use that in this particular problem. All right, write down what you've been given. You have 5.40 grams of hydrogen. Grams always needs to be turned into moles. So 1 mole is always opposite the molecular mass of the compound. So our compound here is hydrogen. H2 weighs 2 grams. So we're going to put 2 grams H2. Now, do we want moles of H2? No, we want grams of ammonia. So remember, to get from one compound to another, you're going to have to use your mole ratio from your balanced equation. So we're going to use this guy to get this piece. So what do we want? We want ammonia. So ammonia is going to go in the numerator. What are we trying to get rid of? We're trying to get rid of hydrogen. So that's going to go in the denominator. Looking at your balanced equation, what is the coefficient for ammonia? 2. What is your coefficient for hydrogen? 3. Do you want moles of ammonia? No, you want grams of ammonia. So now you have to find the mass of ammonia. We know ammonia is NH3, nitrogen is 14, hydrogen is 1 times 3. So 14 plus 3 is 17 grams of ammonia for every 1 mole of ammonia. Now, the only time you're going to use the value from the balanced equation is for this mole ratio. Otherwise, always 1 mole, always 1 mole. 1 mole equals molecular mass. So if you write the molecular mass of a compound, you're going to put 1 mole of that compound. Okay, so now to solve. Remember, if the value is in the numerator, you multiply. If it's in the denominator, you're going to divide. So 5.40 divided by 2 times 2 divided by 3 times 17. How many sig figs can you have? You can have 3. 1, 2, 3. So our answer is going to be 30.6 grams of ammonia. Let's try one more. How many grams of hydrogen is needed to completely react with 6.74 grams of oxygen? We have our balanced equation. First thing I want you to do is identify what you have been given. You have 6.74 grams of oxygen. So we're only going to be using the oxygen. Find what you're looking for. Looking for grams of hydrogen. So you're going to be dealing with the hydrogen. It means we're not going to use water anywhere in our process. So write down what you have been given. 6.74 grams of oxygen. Grams always needs to be turned into moles. Since we have grams, we're also going to have to find the what? Molecular mass of oxygen. So oxygen weighs 16. We have 2 of them. That makes it 32 grams. So molecular mass is always opposite 1 mole. Do we want moles of oxygen? No. We want hydrogen. So we're going to have to do a mole ratio. So we want hydrogen. Goes in the numerator. Trying to get rid of oxygen. That goes in the denominator. The coefficient for hydrogen is 2. So 2 moles of hydrogen is required for every 1 mole of oxygen. Coefficient for oxygen is 1. Do we want moles of hydrogen? No. We want grams of hydrogen. So we got another step here. Grams means you're going to have to find molecular mass. Grams of H2. Molecular mass of H2 is 2. Molecular mass is always opposite 1 mole. So now you can do your math. You're at grams, that's what you're looking for. So 6.74 divided by 32 times 2 times 2. How many sig figs can we have? 3. 1, 2, 3. So our answer is going to be 0.843 grams of H2. So what this is saying is that for every 6.74 grams of oxygen you have, you're going to need 0.843 grams of hydrogen to completely react and give you enough water here.